Alright, 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 alright. Are you guys ready? Let me make sure I'm clicking the right button. Yes! Okay, chat is working. Okay, OBS did not crash. Everything is fine. Spinning at sea, it's Meezy. Hello, everybody! Hello, hello, hello. Can everybody hear me alright? Can you hear the music alright? Hi! How is everybody doing today? Yes, thank you for the nice hat. For those of you guys who do not know, the reason why this stream was delayed by 1 day, and thank you guys again for understanding the delay, is because your girl is published! Let's freaking go! Yes. Woohoo! Well, so, I was just going to do, like, a nerdy stream, but then I realized in order to celebrate and to have some fun while reading some fun astrophysics papers, we would spin things up with the ultimate Wheel of Doom. So yes, I will talk a little bit more about that in the first place, but thank you all so much for the congratulations messages, both here, both on X, Discord, and everything. It has been a wild, wild journey, and I had a lot of fun celebrating. I also just realized I'm not directly looking at the camera, so let me just rotate myself a little bit. Alright, yes, congratulations, thank you! Z, it's late at night for me, and I might not be able to stay long, but congrats on the publishing. Thank you so, so much. Yes, it is a really big milestone. I am super, super excited. Yes, I did publish an article. It's great. Life is amazing. Okay, first off, let's do a quick round of attendance. Hello, Mr. E. Hello, Warpy. Hello, Cillian91. Hello, Astrotropos. Hello, Xenotime. Hello, Eggy Nugget. Hello, Brenda. Hello, Architelos. Hello, Shiraho. Hello, Stella Curie. Hello, Nicoplasma. Hello, Nicoplasma Nico, is also a new science VTuber, if I recall correctly, doing cell biology content. So go check their channel out. Really epic. Hello, Just Juan Guy. Hello, Karma Komodo. Hello, Gilgamesh. Hello, Pembu. Yes, thank you so much for joining. Hello, Warpy. Thank you all so, so much for joining. Yes. I gotta stop saying because I'll talk a little bit more about the Wheel of Doom in just a second. So yesterday I was celebrating publication, stuff like that, so moved to today's stream, but another reason why I thought that moving to today would be better is because I'm sure a lot of you guys have heard, but Gura is graduating, and I have to admit that it's really sad because when I first got into VTubers, Hololive Myth were the first VTubers that I encountered, so just seeing Gura graduate is really just deeply saddening, and when I saw the announcement, I was like, uh-oh, yeah, no, this is probably going to be a graduation announcement. Yeah, no, the community definitely did get KO'd by that announcement. So Astrotropos has been counting the words per minute of all of the VThera members as they read through papers. So, I hope you're not counting it right now, because we haven't even started to read the paper yet, but that will be an interesting data point to look at soon. Architelos says it's the end of an era. Yeah, no, I'm not really sure what's going on over at Hololive, though. I'm hoping that there will be some reincarnation, fingers crossed, we'll see. So, yeah. Alright, so you guys might be wondering, what is this Wheel of Doom in the corner? We've just been hit by a wave of doom from Gura's graduation. How could there possibly be more doom? Well, in order to celebrate, I thought it'd be really cool to have this fun little wheel. Now, if you guys have any suggestions, please let me know. So far, I added up some fun little activities that I could do while we're reading some papers. And that includes standing on tippy toes while reading, which I realized I'm currently sitting, so I'll have to be like theta equals 90 degrees and sort of be at a right angle. Doing a push-up. I would suggest more push-ups, except that I simply cannot. There's also an option to switch to circus music, reading a paragraph without blinking, changing the background image to curse Z, reading while putting my hands up, markering a word to my arm. I'm really scared about this one. And a really nice one, hydrate, which I feel like is a necessity at all times. So I thought it might be fun to do this. And you might be wondering, Z, when are you going to spin the wheel? When will this doom take place? Well, it will take place whenever I use a filler word. And it's not counting right now, I promise you. When I am reading an Astrobites article and explaining something, I want to reduce the use of filler words like... Okay, that was not a good example. Such as, like, and so, and whatever. So, yeah. This wheel is going to be a way for me to gauge how well I am scientifically communicating and avoiding these filler words in conversation. Spin, 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 uh-oh. What word is going to be markered? A word from the paper? Well, I think I'll have you guys vote. We'll have to get to that point first. Like in that contest was not a filler word. Yeah, no. See, look, I'm saying again. Such as, yes. But if you say something like X, that means you're creating comparison, so I guess that's not a filler word. Can we vote for the? No! No! Wait, do you mean vote for the as the word to marker on my arm? Because I'm chill with that. But vote for the as the word that I cannot read? Oh god, this will be a disaster. This will be a disaster. Well, anywho, if you have any other suggestions to add to the Wheel of Doom, please let me know. For now, I'll just be using these ones, which I created very last minute. And yeah. So, okay, so before we get started, I did want to add and too. And? So I can't say and? Well, I guess if I say more than two ands in a row, so if I say something and something and something and something, then I guess that is sort of a filler word. Yeah, I guess that counts. Is that the CMB as your dress? That's really cool. Yes, I am the Cosmic Microwave background, and we're going to be talking about that too. Before I go on, just as a brief announcement, I have this all jotted down. There will be no stream this Saturday because it is actually Syzygy's birthday. And I believe she is doing a really epic stream, so go check her out. And you can access all of the VTheorem members, which is the group that I'm part of, using the !VTheorem command. Woohoo! And another thing that's sort of been in the works is I'm hopefully planning to do a... Fingers crossed. I'm hopefully planning to do a 2,000 subscriber milestone celebration soon, which is going to be super, super exciting. I'm super stoked to share that with you guys. The Syzygy Discord is even open. Yes, yes, go join Syzygy's channel. For context, for those of you who do not know, Syzygy is a psychologist VTuber who does amazing psychology content. I guess that YouTube link, I think she posts her VODs there, but she primarily streams on Twitch. Okay, that's enough logistics. We're going to lock in. We're gonna lock in. Orbeez, are you ready to lock in? Because we're ready to read these Astrobites articles. The first one I found... Okay. For a second I thought things were gonna bug out. Is this your paper? No. Well, okay, so... I am not going to disclose, like, none of these are my papers. I'm never probably going to share any of the papers I actually create, just because it has very high doxing potential. Although, one day, maybe. So this is about the Einstein lens. I thought this would be really cool. This one's a little bit old, but I absolutely love this. Yes, I am posting a link to the paper right now. So this is the, yes. Oh, I guess there's, oh. And if you click that first link here, that is the actual link to the paper itself. So for those of you who do not know, Astrobites is a website that takes existing research papers and sort of translates them into ways that are accessible for a lay audience. When I first got into reading articles, I didn't really know where to start. And Astrobites is one of the best platforms to start reading papers, especially in astronomy, very regularly. They primarily focus on astronomy. They only focus on astronomy content. But I believe there's also, out of Astrobites, they've also had other spin-offs in like biology and chemistry and so forth. So yes, definitely go check it out. And I thought this would be a really great way to sort of delve into a paper without having feelings of being overwhelmed by all this jargon. And I have to admit, some of these topics are also sort of new to me too. So this will help explain things a lot better. Z-Bites when? Maybe. Maybe I'll do a Z-Bites. I think my YouTube shorts are sort of like Z-Bites though. Drinking some lemon ginger tea. Can't wait for cheesy bites. I've been craving cheese so much. Alright, let's get started. This also means that the Wheel of Doom is beginning. So no more filler words. And if you catch me using a filler word, call me out in the chat. Hello, Professional Skill Issue. Hello, Salt. Oh, thank you so much for stopping by. Okay, let's get started. Zigzagging across the universe. The title is J1721 plus 8842. That sounds like... is like in this context okay? I think it's okay. That sounds like a very funky name because it's the name of the Einstein lens here. And the first author's institution is the European Southern Observatory. Very, very cool. In Chile. Amazing. Let's get started. That like is okay. Yes. Okay is a filler? Okay is a filler? Okay, no more. Oh, no. Ah! I just shouldn't talk anymore, Orbeez. Let's get started. No, please don't change usernames, please. Let's get started. Light doesn't always travel in straight lines. It travels along the shortest path through space-time. Space is pretty much flat on our small scales, so light travels in straight lines. However, on cosmological scales, space can be distorted by massive objects. If space were to be stretched by a galaxy's strong gravitational field, then it would act like a lens by deflecting light. The shortest path in this bent field is a curve. This is basically explaining that light travels along the shortest path. And the way that gravitational lenses work is that the immense gravitational field of a galaxy bends the light so that the light curves around the field. Orbeez, you're stressing me out. Okay, maybe I should clarify. Ah! Z says a filler word. Okay. Alright. Nothing happened. Now, if that galaxy lies between us and a very bright distant object such as a quasar, the gravitational field from that intermediate galaxy will focus the light from the quasar to create a lensed image of the quasar at Earth. Sometimes those images can be smeared out into an arc. I'm curious to see what this image will be. Ooh! This stretched out arc is a galaxy cluster bending the light of a star-forming galaxy in the background. This is a galaxy that's being distorted by this bigger galaxy cluster. That's a really cool image. Sometimes those images produce stunning Einstein rings. Oh yes, if you haven't seen these are spectacular. These are beautiful. You might be wondering what these rings are. These are circular galaxies but the galaxies themselves don't actually look round. Thank you, Agent Sinistra, for subscribing. And rather, they are actually being bent around. Oh, thank you, Roswine, for subscribing as well. They are being bent around by a larger galaxy that is, or galaxy cluster that is blocking the view of the galaxy itself. Einstein rings are some of the most beautiful things. What do you give someone when they've published something? I'd say, in general, just going out for dinner. Okay, I'm gonna use some filler words here because I'm actually really thinking about what a good gift would be. I've seen in larger papers, flowers, chocolate, the sorts. Yeah, something along those lines. I've seen those. Ooh, cash, you give them cash. No. Oh, is a filler? No, you can't do this to me. You can't do this to me. Einstein rings and crosses are so cool. Yes, they're one of the most beautiful things. I used to have an Einstein ring gallery as the wallpaper of my phone. Sometimes these images produce stunning Einstein rings, sometimes they remain point-like. For an example of a gravitationally lensed image, see figure 1. Cool. The 6 points of light labeled A through F are multiple images of the same distant quasar. However, this picture is not just any gravitational lensing event, but a doubly lensed event, where the light from the distant quasar is lensed by 2 intermediate galaxies and zigzags across the universe. This is absolutely spectacular. When I encountered this paper, I was blown away by this. Oh. Was it a filler word? Me just saying, oh? Hopefully not. Orbeez, what do you think? In the meantime, I'll explain what's going on here. A, B, C, D, E, F. These all look like different things. These are all the same object. This is one quasar being distorted across a galaxy cluster so that it appears like 6 objects. What? This is crazy. I don't think so. It's majority no. It's majority no. I'm safe, I'm safe. Einstein hexagon. Yes, it does look like an Einstein hexagon. Thank you, Just One Guy, for subscribing as well. You guys really want me to spin. Maybe I should spin for every subscription. Just because there's been a lot of Orbeez who've been subscribing. I think we've already had 3 so far. Would you guys like that? Or if you subscribe? This is so cool and kind of hurts my brain trying to wrap my head around it. Yeah. When I first encountered this, I didn't believe this either. Especially since E and F look like clouds. Yes, so you might be wondering... Oh, I did just say so. Okay, I think I have to spin the wheel now. I think I've made up for it. The Meese Man asks, how do we know for sure if it is the same object? The paper is going to go through that in just a moment. They describe the method of spectroscopy, which we will explain in a second. But first, let's spin the wheel. Orbeez, how many times should I spin? Should I spin for the 1 filler word that I used, or maybe the 3 subscribers as well? I'm happy to spin it 4 times, but that also means, Orbeez, you'll have to suggest some more ideas because we're going to expend this really quickly. Let's spin it 1 time for now. Just 1? Alright, just 1. 4! Professional skill issue, you're gonna kill me! Ah! No! 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 1, okay. Oh, what am I gonna do? What am I gonna do? Orbeez! Actually, this paragraph is not bad. I think I can read this without blinking and without filler words. And please suggest more ideas for the Wheel of Doom, since I only wrote in a couple of things. Oh, let me also make this... Oop. Let me also make this a little bigger. Poor Z always suffers with these punishment things. Yeah, no. You have to roast your favorite... No! Roasting your favorite scientist? No! Okay. We're gonna read this without blinking. Okay, let me... I even have my contacts in, so this is gonna be a little bit painful. Okay, 3, 2, 1. When J1721 plus AA42 was first analyzed, researchers didn't conclude that this image showed one distant quasar being doubly lensed. They concluded that the red arcs in figure 1 were another galaxy at the same distance away from us as the quasar at a redshift of z equals 2.382. They thought that they were both being lensed by one galaxy at a distance of redshift z equals 0.184, which I'll call lens 1, which is the white fuzzy blob in figure 1. Ah! I survived! I survived. Okay. Let's break down what was being said here. I saw blinking? No, that was my model glitching. I actually read this without blinking. Let's break down what was being said, though. 2 blinks! No, I read it without blinking, I promise. You ever think of becoming a rapper? Whenever I go karaokeing, I only do rap, actually. I actually think I'm pretty decent at rap. So... Ah! Okay, well... Alright, we're gonna explain the paper now. What this is being said is that the researchers, when they first saw this image, thought that this was a bunch of different objects. Turns out, it was one quasar being doubly lensed so that it appears 6 times. And there's going to be a diagram later on that will show how this galaxy is lensed. Oh, here we go. And what these deflectors here, they describe this here, this idea of redshift, that is a measure of distance. This shows that there are 2 deflectors, 2 galaxy clusters, or galaxies, in this case galaxies, that are deflecting the light so that the quasar is lensed twice and appears 6 times. The researchers found this out by doing spectrography, which this link here, if you are on the page, describes this more in detail, but the general summary is that the spectral lines... I'm trying not to use filler words. The spectral lines of an object say a lot about the object's properties, including its composition and, most importantly, its distance. And that's because the scales of these quasars are so distant, the scales of these galaxies too are so distant, that by the time the light of the galaxy reaches us, it appears redder because the universe has expanded, it's stretched, it's the Doppler effect, basically. And when something appears redder, their spectral lines shift towards the redder end of the spectrum. Therefore, by using spectrography, the researchers looked at the spectral lines and determined the distances of the galaxies in between the quasars and us, and found that there were 2 lenses. The first is this in-between galaxy, lens 2. And then lens 2 is also then being lensed by lens 1, which creates these red arcs. And you can see this here with the pink and the blue lines. Figure 2 shows a visualization. Yes, I think this really depicts what's going on here. The reason why this system is doubly lensed is because there are 2 deflectors at these different redshifts. And Z represents redshift, Z like Syzygy. And the quasar source, which is what's being shown in the letters, is here on the right. This is absolutely spectacular. The Large Hadron says, I'm in physics and astro sounds so foreign to me. I think it's spectacular though. Imagine explaining to somebody that you saw a quasar 6 times in the same region of the galaxy because of the power of gravity. Isn't that impressive? All right, we're gonna take a bit of a break because I used all my brain power not to spin the wheel again. More songs don't count. Punishment idea, karaoke a rap song. Ooh. I don't really know any rap songs. I know a little bit of Calliope Mori's, the one that's like, getting kind of stir crazy, you heard this? Oh, well, I'm forgetting what it's called. I'm wondering what the meaning of lazy or life without work is. Kawaii Shinigami at your service. Orbeez, do any of you guys know what this song is? I think somebody also suggested rap a paragraph. That's also a great idea. So all these dots are the same star? Yep, that's correct, including E and F, which just look like fuzzy clouds. Is this RIP? I don't think so. I think it's, or maybe? I'm not sure. Oh, I think Pembu suggested like ooh-ify a paragraph, which is talk like the astrologer. Is it? Oh yes, okay, I think Xenotime is correct. Probably RIP, yeah, I think it might be. Talk like the astrologer for a paragraph. It might be the song after, it's called Deadbeats. Yeah, it's one of the two. It's one in her debut album. I'm blanking on which one it is. All right. Next paragraph. It looks like a halo if it lines up exactly. Yeah, it sort of lines up. I think what's being implied here are these 4 points are sort of on this square. I'm not really sure why they plotted it as a square. Though Einstein lenses shown here are circular. Hence, they're called a lens. All right, next paragraph. Images A, B, C, and E are deflected in the same directions by lens 2 and lens 1. Meanwhile, images D and F are deflected in opposite directions, creating a zigzagging path in between them. The image of the distant quasar is zigzagging across the universe because 2 galaxies are deflecting its light in opposite directions. Isn't that so cool? Yes, it is so cool. This is absolutely amazing. You'll also notice that the images smoothly curve out before they are sharply deflected by lens 1. This is because of cosmic expansion. 11.67 words per minute. I hope that's good. These quasars and these galaxies are so far apart that cosmic expansion is affecting the light arriving at us. We haven't observed double gravitational lenses before. This chance arrangement of galaxies where 2 strongly lensing galaxies are in the same line of sight is the first to ever be observed. The zigzagging path is expected to occur in 1 in every 100 million lines of sight. This is insanely cool. Yes, Xenotime, you are correct. This is insanely cool. All right. You might be wondering, why is this useful? A doubly lensed item is very, very cool. But one of the reasons why this is really cool is because of this idea known as the Hubble tension. Let's read this. Beyond the sheer awesomeness of this observation, this system may help us resolve one of the biggest problems in cosmology today because of the unique zigzagging and the constraints that this path can put on cosmological parameters of interest. This problem is the so-called Hubble tension, also known as the crisis in cosmology. If you click on this link here, there is some information about what the Hubble tension is, but before the stream I actually jotted down some notes to help explain what this is. The idea of the Hubble tension is that we don't know how fast the universe is expanding. The earlier universe is expanding at a rate slower than what we would predict and what we're observing in the recent universe. And this expansion rate is described by this parameter known as the Hubble constant, which you may have read in some news articles or papers about easing the Hubble tension or constraining the Hubble constant and so forth. And there are many different ways to figure out how fast the universe is expanding. One of the ways is through me, the cosmic microwave background, tracking the fluctuations. And if you look at my shirt, you can see a lot of fluctuations up and down. It's not entirely uniform. There's some red and blue regions. These fluctuations actually map the density of early material in the universe. If you think about it, in the early universe, the universe was much smaller, and there were some clumps here and there. Then, as the universe expanded, these tiny particles in those clumps would gather more and more mass, and over incredibly long periods of time, those overdensities, those small overdensities on an incredibly tiny scale, became galaxies and galaxy clusters. So looking at me, or the cosmic microwave background, can help track the density of matter in the early universe. Another way to measure the expansion of the universe on a more recent scale is through supernovas. And the reason why we can do that is because we know what the brightness of a supernova is. So if you envision, let's say that you have a flashlight and you know how bright the flashlight is, and you place it really far away, then you'll know that it will look really dim. But you also know how bright the flashlight was when you were holding it. And when you account for that difference, you can actually determine the distance. A similar method is being used with supernovas. Although this is highly contested right now, in an ideal world, we know how bright a supernova is. So when we see a supernova take place in a really distant galaxy, we can say, oh, this supernova looked that bright to us, which means we can measure its distance. And by measuring these distances to all these different galaxies, we can determine how fast the universe is expanding. It's cool because it has a lot of Z's in it. Yep. Why was gravity able to stick stuff together, but then we predict entropy will disperse all matter? I'm not sure if I quite understand what you mean. Entropy doesn't necessarily disperse all matter. Entropy just means that, if you drop a glass and it shatters, there's no way to reverse time and put it back together again. It doesn't necessarily mean that things will expand. For instance, if you have a volume of gas, and I don't know if this is the best example, but if you have a volume of gas and those gas particles start moving around really quickly, the entropy is increasing, but the volume stays the same. Why is it... Oh, shoot. Did I say I'll spin the wheel right after I explain this. Why is it contested? Currently, scientists believe that our measurements of how bright a supernova might be inaccurate. Because we've been noticing situations where supernovas are brighter or less dim than they expected, and not always the same. And this is for a very specific type of supernova known as a type 1a supernova. And if these supernovas are at different brightnesses, then we can't really use them for the same standard measurement that we have in the past. How do they know how bright it's supposed to be? I believe it's through various measurements. One of the reasons is because a type 1a supernova is created when a white dwarf and a bigger star are exchanging mass with one another. And after a certain point, the white dwarf gains enough matter to undergo an explosion. And we know what that limit is through physics. It's called the Chandrasekhar limit, and it's 1.4 solar masses. Therefore, when a white dwarf reaches 1.4 solar masses or beyond, then it should explode. And by knowing that mass, we can estimate how bright it should be. I feel bad for asking that question. It's okay. We're gonna spin the wheel. We're gonna spin the wheel. How do I do this? Ah! This is actually not too bad. Changed background to cursed Z. I'm gonna miss this background a little though. All right, let me change my background to cursed Z. I think this one should be fun. I really like this one. I have various cursed backgrounds that we can use. I think this was from an anime. I don't know what anime this is from. Neon Genesis Evangelion or something. All right, this one's chill. This one did not make me, oh, that was for later. Did not make me suffer too much. All right, back to the paper. The reason why this idea of a Hubble, oh no, thank you. Oh, your username is very cursed. Thank you, individual, for subscribing, which means I need to spin the wheel again. No. Rap a paragraph. Ah, my rap is so cringe. I have not watched Evangelion. Yes. All right. We're gonna wrap this paragraph. Do you guys define rap as speaking really fast, or does it have to have rhythm or something like that? Because I can read it really fast. I don't know if I can incorporate rhythm into this paragraph. It has to be rhythmic? Alright, alright, alright. Locking in. Take a look again at the paths that images A and D take in figure 2. Image D zigzags between the two lenses as the image is deflected on opposite sides of each lens, while image A is lensed on the same side of both lenses and follows a more straightforward path. Image D travels a longer distance from the quasar to us, and this extra distance results in additional relative travel time compared to image A. Hence, image D is affected by cosmic expansion for longer than image A. While a single lensing event can produce some constraint on some cosmological variables that affect cosmic expansion, which include the Hubble rate h0 and the equation of the state of the universe W, a zigzagging double E lens path provides an even stronger constraint when compared to the simpler path. That was so cringe! This is actually really good. What are you talking about? Orbeez, please share this with my senpai Mori Calliope. I have my finger ready on the clip button. Oh my god. Oh, this is giving me third-hand embarrassment. It's okay. It's okay. Please send this to Mori Calliope. Please let me be noticed. I love Mori. I absolutely love her music. I can never be her. All right. So what happened in this paragraph? What this is saying is that image D, this one, travels a longer distance, this pink line. And this extra distance results in additional relative travel time. And what the authors conclude is that image D is affected by cosmic expansion for longer than image A. And that small difference in how much that light travels can give us a constraint on the Hubble rate, the rate of expansion of the universe, and the equation of the state of the universe. And this zigzagging path can give us a lot of information about cosmology itself. It's in the Discord now, preserved forever. No! Hand delivering this to Mori senpai. Oh no. Thank you, Alright, next up. This discovery is extremely important for cosmologists because of the current discrepancy and growing inconsistency between measurements of H0 and W between different experiments and observations. Further analysis of the system with time-delay cosmography may elucidate an answer to these discrepancies. In addition, further observations will help us understand the distribution of mass within the galaxy of Lens 2. This will be important to help us understand the characteristics of populations of galaxies during the first few billion years of the universe, and how they evolved to the galaxy universe that we live today. What this is saying is that This is sick. This is really cool. And it also is really cool for understanding our universe and easing this huge question that cosmologists have had. Woohoo! And that is one article. Thank you, William Lamb, a fifth-year PhD astrophysics candidate at Vanderbilt University. Wow. Very spectacular. This was one of the coolest articles I've encountered on Astrobites. All right, Orbeez, what did you think? Rate this article out of 5 stars. I personally would rate this out of 5 stars. Do you accept cosmology paper suggestions on stream? Actually, how about this? I think it's better if you send them on the Discord because links don't send on the YouTube. And I'm hoping to... Alright, I'm gonna use some filler words now. I'm hoping to actually do a cosmology paper read on stream sometime. The thing about reading papers on stream, though, is that you have to be a little bit cautious. Astrobites, I believe, has some copyright regulations, but I think they allow you to actually like stream it or provide commentary on it. Some of the research papers, I don't think you can stream. So if you have a cosmology paper you'd like me to read, send it over. I'll check it out regardless. And if it's something that can bypass copyright regulations, then that'll be cool. 20.79 words per minute. That's pretty fast. 5 out of 5 stars. Would have been 4.5 out of the 5. But the rap made it a 5. Let's freaking go. Let's freaking go. All right. That was article 1. All right. This one is pretty... This one's a little bit more scientific. I actually had this in my list, but then this article came out yesterday and I wanted to go over this one. So we're going to replace it with this one. This one was really cool. Paper was good. It started your rap career. Orbeez, do we want to do a rap karaoke for the 2,000 subscriber milestone? All right, this, I'm going to provide a link to this paper. Bullet cluster paper. I actually have to brainstorm some ideas for the 2,000 subscriber milestone. Yeah, one other thing. I'm hoping to get my violin, so my violin is like back at like my childhood home, which is like far away. And so I'm thinking about hopefully having my violin with me in the next few months or so. We'll see. And I'm sure you guys would really love another violin cover and or a violin karaoke. I'm thinking for 10,000 subscribers, when we hit that milestone, there will be a violin karaoke because I think that's the most in-demand thing on my channel right now. Syzygy's doing a karaoke thing soon. Soon, as in this afternoon? Ooh, that might be cool. Rap collab? Actually, Syzygy and I have been talking about potentially collabing soon because she's the only VTuber member I haven't collaborated yet with, so that would be really cool. Alright, be sure to hydrate. I'm drinking some lemon tea. Alright, cool. Yeah, collab soon. I don't know about this afternoon, but she had a point goal and it passed. Ooh. Well, I definitely will need to check in. Maybe that'll be cool. I think Syzygy is probably a better rapper than I am. Yeah, oh, another thing on the agenda. I don't know if Xenotime's still here. Wink, wink. But there may be another collab in the works. Very, very soon, actually. Actually, in T-minus 10 days, technically. Which I'm very excited for. And I'm sure you guys will be excited for it, too. Yay! Xenotime is here! Yeah! Wink, wink. There's a collab soon. Wink, wink. I think it'll be really cool. I'm actually very, very, very stoked. Alright. Orbeez, are you ready to read the next paper? Alright. I'm going to have to be careful with filler words, though. Let's see. NCIS JWST, analyzing the aftermath of the bullet cluster's collision. And the link... I did just say, Alright, I'll spin the wheel just to get things started. But before I do that, and I just said again. The paper is linked at the top of the Astrobites article. There you go. Alright. Alright, Orbeez. Let's see. Oh, God. Please let it not be push-up. Please let- No! 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 Oh, circus music! Oh, that's circus! Let's freaking go! I dodged push-up so close. Alright. I hope the music won't be too loud. I do have circus music saved already. Loop file. I don't know how loud that is. Let me see. I think. Let me. Is that too loud? Let me see. I think. Oh, it's actually not too bad. Rap to circus music? Oh. Wait, this circus music's a little crazy though. Orbeez, you guys really like hearing me rap? Rap to circus music? If you have more ideas, feel free to suggest as well. Alright, that was the first article. Next article! Let's read this. And if you're lurking and haven't subscribed, you could also subscribe and make me endure more pain. Let's start. Despite the extreme depths and resolutions of the James Webb Space Telescope, there's still no smoking gun. That's an interesting analogy. To be found in the hunt for dark matter. I have never heard the phrase, no smoking. What does that even mean? Push-ups to circus music? I'll add that to the thing too. What does there's still no smoking gun even mean? Does that mean there's no direct answer? I understand what this sentence means, it's just odd. Clear evidence, hard evidence. Sure, yeah. Yeah, that's an interesting analogy. I'm wondering if your subscriptions are public. Oh, huh. Oh, thank you, Pembu, for the reminder. Like, if you're a crime scene and there's someone with a smoking gun, it's very obvious you did. Oh! I guess I'm just not familiar with English. That's a pretty common phrase. I guess I've just never heard it before. There's no smoking guns in space. Yeah, exactly. Alright. Yet, the extremely high velocity collision in today's paper might aid in the search for what this mysterious material is made of. Now, I chose this because the bullet cluster is one of my favorite galaxy clusters, and this will explain why in just a second. The target of today's paper is the bullet cluster, and despite its name, it's not one, but actually two massive clusters of galaxies gravitationally interacting with one another. Due to the high speed with which the smaller bullet subcluster collided and passed through the larger one, a strong bow shock caused the gas in the system to compress and heat to millions of degrees. Typically, this alone would allow the gas in the system to compress and heat to millions. Oh, make this system interesting to astronomers, but the real kicker here is that this collision was powerful enough to separate the dark matter from the normal luminous matter. This has made the bullet cluster an important testing ground for theories on the nature of dark matter and what the authors of today's paper attempt to use it for. To summarize, the bullet cluster is one of the first instances where we've indirectly observed dark matter. Oh, it was a pun? What? Smoking gun? Oh, for bullet cluster! That's genius! Oh, that's smart. Veronica Dornan cooked so hard on that one. Veronica Dornan is like that meme with the increasingly bigger big brains, and she's at the very bottom. That's spectacular. Send the paper suggestion in Science Corner. Thank you so much. I'll check it out after the stream. Yeah, that's a bloody good one. Yeah, no, this is great. Alright, to continue. What's going on here is that this blue region represents mass, and this pink region represents X-ray, and this green region represents radio. And you might notice that the blue and the pink regions are separated. That's because the mass measured by James Webb, it indicates the gravitational lensing strength, which then indicates how much matter there is in total. But if we were to measure the gravitational lensing that takes place, you can observe the dark matter passing through the galaxy cluster. And that's because dark matter doesn't interact with basically anything. It just passes through, whereas the matter interacts and slows down because of gravity. I hope I didn't say a filler word in there. I got really absorbed. The bullet cluster is really spectacular for that reason, because it is an indirect observation of dark matter at galaxy cluster cosmological scales. Oh, and hello, Brian Nowak. Mapping hidden mass. What these authors do is that they used JWST imaging, James Webb Space Telescope imaging, which captured the majority of the bullet cluster system to obtain high-resolution multi-wavelength data. They then identified over 146 areas in the image subject to strong lensing, which is when the light from a background galaxy is bent around the mass in the foreground bullet cluster system. This is really similar to the paper we read before. Instead of now we're using gravitational lensing to determine what the mass of the bullet cluster system is. You would imagine that the more mass there is, the more gravitational lensing takes place. Because if there was a galaxy in the background, that light would be more distorted as it arrives to us. They also obtained a weak lensing model for the image through statistical analysis, since the effects of weak lensing, while similar, are much more subtle than strong lensing. Hello Luak, what are we doing? We're reading a paper, and if I say a filler word, or if you subscribe, I have to spin this wheel of doom. So I'm suffering right now. They then created a mass map for the system by feeding their strong lensing and weak lensing. Super normal stream happening right now, yes. By feeding their strong lensing and weak lensing model into the reconstruction algorithm. Essentially, this algorithm creates the most likely distribution of mass, both dark matter and normal matter, that will recreate all the lensing that they observed. This is impressive, Orbeez. What the author is saying here is by feeding a physical model of lensing, the computer was able to determine the most likely distribution of mass. The Doom OST, I'd have to download that, but yes. Oh, wait. That might not work because this is actually copyright-free clown music. It's not just any clown music, it's copyright-free clown music. But if I play Doom music, it'll probably get copyright striked and I'd have to cut out the entire VOD. Sad. Figure 2. Comparison of the dark matter mass map. Multiple figure 2 to the thing I'm working on right now for like real research. Oh, that is so cool. Wow, no, that's really cool. So you're basically working on stuff like this. Maybe not the bullet cluster though, but that's really cool. Comparison of the dark matter mass map from the strong and weak lensing data and the distribution of light. Note how the bottommost centroid's dark matter and ICL contours are offset from one another. So the lensing is this pink region, and the BCG, the brightest cluster galaxy, and the ICL. Sorry, what was that again? What is the ICL? What is the ICL? What? What is the ICL? From the ICL? Is this just like the intercluster medium or something? I'm gonna Google this real quick. Intracluster light. So I guess it's pretty close. So the ICL refers to the faint diffuse light that permeates the space between galaxies. Yes. In galaxy clusters, the gaps between the galaxies aren't empty, but they're filled with intergalactic medium, which is what I originally thought ICL stood for, but turns out ICL stands for intracluster light, where there's light in between as well. That makes sense. What's special about the algorithm they used here is that it does not assume that light traces mass. In general, this assumption is correct, so other algorithms use it to get the most accurate mass estimate. But the authors here wanted to confirm that even in extreme environments, like the incredibly massive bullet cluster, this is the case, so they sent their algorithm in blind. Interesting. I guess they will go more into detail in a second. What is dark matter? That's a great question. That's what a lot of people spend their entire lives wondering. For context, dark matter makes up about 25% of the universe, and we have no idea what it is. For context, everything you can see, touch, and interact with, normal matter, makes up a mere 5% of the entire universe. Everything else, we have no idea what it is. And dark matter, we know that it exists because we've been able to measure it in instances like the bullet cluster. We also know that, this is a really cool tidbit, that galaxies form at the center of dark matter halos, which are basically concentrations of dark matter. Galaxies form at the center of those halos. But we actually know very little about its properties. We know that it doesn't interact with the electromagnetic force, which is why we can't see it directly. It does interact with gravity, in the case of galaxies and so forth. So it's the same as we don't know stuff, exactly. And what's really cool about the dark matter question is that there are so many different ways to look at it. I've seen instances where people have I know of instances where people have explored dark matter at the particle scales. There's this idea known as the hidden valley. I'm not sure if this is 100% correct. If somebody is a particle physicist in the chat can correct me on this. But if I recall correctly, the idea of the hidden valley is that dark matter is in this separate dimension from us that we can access only using high energy. And the reason why the Large Hadron Collider is so important is because it is our most powerful particle accelerator. And some scientists believe that we can access those higher energies and reach into this hidden dimension and get these dark matter particles out and explore their behavior. That's one way to approach it. There's also people who've created large tubs of liquid or gas trying to make dark matter interact with at least one particle underground, and so forth. So there's a lot of ways to, I think I've said a lot of filler words. There's a lot of ways to interact with dark matter and explore the dark matter question. I'm particularly interested in instances like these with the bullet cluster, where we're exploring the dark matter question on a cosmological scale, where the presence of a lot of dark matter particles can indicate how it behaves on these larger scales. If it doesn't interact with electromagnetic field, would it be able to go through matter? Yes. If I recall correctly, dark matter just goes through matter. Though in dark matter halos, larger conglomerations of dark matter, they can contribute to the formation of galaxies. But if you're talking about an individual particle, for instance, I mean, there's no way for us to actually detect it. And there have been a lot of experiments trying to detect it with varying constraints and success. Yeah. Literally a giant super sensitive radio to search for signals of a dark matter candidate called the Axion. Yep, this dark matter question is one of the biggest questions, if not the biggest question in our universe. 22.17 words per minute, currently second. Who is first? All right, Orbeez, we gotta lock in. We gotta read this fast. Maybe I gotta spin the wheel and get the rap again. What's special about the algorithm that they used here is that it does not assume that light traces mass. In general, this is oh wait, we already read this. Once they had their mass map, which is dominated mostly by dark matter, they can compare it to the optical light, or the light that we observe between the system's galaxies. I see, referred to as the intra-cluster light. They use a statistical test called the, oh my god, I have no idea what this is. Oh, what? The Hausdorff distance, to determine how similar the distribution of the light and the dark matter were to each other. They found that despite the extreme gravitational interactions going on in the bullet cluster, the ICL still does an excellent job overall of tracing the system's mass. So I see. These scientists used the intercluster light, and from it have been able to predict the extreme gravitational the system's mass despite the insane gravitational interactions taking place. Phi has won on record and crushed everyone else. That's crazy. Well, second place is still second place. Interesting question above. If they can go through matter and interact with gravity, shouldn't they cluster in centers of gravity such as the Earth's core? Dark matter, we do not know how dense dark matter is, but given the fact that it's been almost impossible, basically impossible to detect at the Earth particle scales, the Earth is not gravitationally strong enough to potentially attract dark matter. That being said, this is a hard question to answer because we don't know anything about dark matter. It could be just everywhere. But one theory about dark matter that could be like primordial black holes, or it could be particles, or so forth. It could take shape in many different ways, and we haven't been able to determine which one exactly it is. But one way that this is applicable is that dark matter can cluster on incredibly large scales, helping to form the structure that leads to the creation of galaxies. At the center of these like dark matter halos, these spheres of dark matter, galaxies can form, which is an indicator of the behavior of dark matter with gravity. I just mean it as an example of a potential body. I mean, maybe there could be dark matter, but we wouldn't be able to detect it. It would be impossible to detect. Our real matter is probably just insignificant. Yeah, exactly. We do know that dark matter makes up 25% of the universe, but we don't know what that looks like. There are so many questions out there. You know what would be really cool? Thank you for these questions. Honestly, this gets me thinking. Orbeez, would you guys want a dark matter stream? I think it would be really cool to explain the ways that people are searching for dark matter across the particle and the cosmological scales, and explaining some recent research on dark matter as well. Or even focusing some Astrobites articles on dark matter. Is dark matter observable? Yes and no. Because you can't observe it, like light, for instance. But what you can observe, which is the case for the bullet cluster, is that you can measure the gravitational lensing that's taking place. As in, how much are galaxies in the background being distorted by a huge galaxy cluster? And from that, you can determine the distribution of mass in dark matter. I'd be totally down. A dark matter deep dive. Yeah, here, let me jot this down real quick. Dark matter deep dive. What is normal matter? The scientific definition is material made out of standard model particles. But in English, what that means are particles that you can see, touch, and interact with. Basically, everything that you can see is normal matter. That even includes like electromagnetic radiation and that kind of stuff. What are the particles made from? Oh, well, that's a rabbit hole. I mean, protons, neutrons are made of quarks. Quarks are fundamental particles, which means that from our current understanding, they can't be broken down any further. Everything the light touches is our kingdom. Yes, exactly. Alright, let's keep on reading this paper. Next, the scientists compare their mass map to the distributions of hot plasma, as observed in X-ray wavelength with Chandra, the X-ray telescope, and of hydrogen gas, as observed in radio wavelengths with Meerkat. Let's see what Meerkat is. Ooh. Oh. I hope this didn't, like, dox where I'm from or something. Hopefully not. South African Radio Astronomy Observatory. Cool. Yeah, I don't think that showed any information. They found that the dark matter was offset from both of these distributions, which was already known. Yes, the dark matter was offset from the normal matter, which is why I was mentioning that this is an indirect observation of dark matter. However, their measurement of these mass offsets indicated that it's unlikely that the bullet cluster was formed from a merger between just two galaxy clusters. The authors suggested that the bullet cluster formation is more complicated than previously thought, but aren't able to give any guesses about the initial conditions. That could imply that there is another galaxy cluster that could have also collided in with the system. Warpy, I have to go to bed now. Have a good night, Warpy. Thank you so much for stopping by. What a massive cluster tells us about a tiny particle. Finally, the authors were able to use their mass map to put some constraints on one of the theories of dark matter, self-interacting dark matter. If dark matter particles interact with each other, then they have a cross-section which can be calculated. So, the idea of... Oh! I just said so! Oh, shoot! Oh, shoot! Orbeez, no! No! It's okay. Okay, let me first explain what self-interacting dark matter is first. So oh my god. Self-spin, no! Self-interacting dark matter is this idea that these dark matter has a dark force that can lead to dark matter particles interacting with each other at the center of galaxies. And this is important because in an incredibly high density dark matter halo, which surrounds a galaxy, there could be these interactions taking place between the dark matter that heats up the galaxy and is one of the ways we could observe dark matter. And this is one of the theories of dark matter. Yeah, cross-section is a formal version of how probable an interaction is where two things collide. Yep, exactly. And when the authors explain that they have a cross-section that can be calculated, they're implying that if dark matter particles interact, there's a way for us to determine the probability of which that they interact. And they actually do that with the bullet cluster. But before we go into that... Orvis, send help! Send help! Okay, it's not push-up, it's... Oh, no! No! Orvis, I'm cooked! Orvis, I'm cooked. Oh, let me get my markers real quick. Oh, they're in my bag here. Oh, no. Where are my markers? Orbeez, you need to vote on a word now. Alright, Orbeez. The council shall meet. I just came in, what's going on? I said a filler word, which means that I have to marker a word to my arm. And you guys can vote in the chat while... Give me some suggestions in the chat while I explain why this bullet cluster helped determine the cross-section of dark matter, or the interaction probability. I think something cool for a word will make cool. I'm not opposed to writing the word galaxy on my arm, or like dark matter, right? Can it be a phrase? Okay, some ground rules. No, not certified astrologer. It can be a phrase, but please nothing like inappropriate or weird or sexual or something that I can't, you know, like pull up to a meeting with. Certified astrologer? No! Orbeez, you can't do that to me! I'm like sad. Alright, I have 3 colors. I have green, blue, or black. Ether girl? That's also kind of nice too. Number 1 astrology fan? No! Ligma? No! Oh no! I actually watched the Minecraft movie this past weekend, and now my brain is full of brain rot. Oh god. Justice for A. Oh no. If I write something like A the I think even if I wrote certified astrologer, if one of you guys see me in the wild, then you'll know it's me. Astrology time? Oh no. Oh no. Alright, Orbeez. I see a few chicken jockey, galaxy. Oh wait, galaxy jockey's not bad. All right, let me do a poll. I think Ligma might be a little bit weird. Live, laugh, love. That's actually not too bad. All right, so let me put the 4 options that I kind of see in here. Number 1 astrologer. I think that's roughly the same as certified astrologer. Chicken jockey / astrology jockey. Or galaxy jockey, I actually don't oppose that. Astrology time. Voyager enjoyer, that's actually cute. Not too bad. Automatic, no, I feel like it. Astrology time. Dark matter release. Alright, I think these are the 4 that I've been seeing in the chat. Alright, Orbeez, vote. And in the meantime, I'll explain what's going on here. Here, the authors calculate the probability that dark matter interacts from the offset in the position of the most massive galaxy in the bullet cluster, and the position of the highest density of dark matter. And they got this number. And this is crazy because this is the tightest constraint on self-interacting dark matter's cross-section, or the probability of interaction. But we still have that pesky program units because we don't know the mass of the dark matter particle. But this is being studied. Ooh, there's another Astrobites article here about... Oh, this was actually quite recent too. about the mass of dark matter. The cross-section is on the lower limits of what is thought to be reasonable range for self-interacting dark matter theories, but certainly doesn't rule anything out. For further context, we have some information about hydrogen. But this is great. They use the bullet cluster, which the reason why I really like this Astrobites is because it takes the bullet cluster, which is this huge cosmological scale galaxy cluster, and they use it to constrain something on the particle scale. And I think that comes to show how connected the fields of physics can be, from the particle scales to the cosmological scales and so forth. So yeah. Altogether, the authors of the paper were able to use both the precision of JWST and the impartiality of their mass reconstruction algorithm to learn new things about the structure of bullet cluster and the nature of dark matter. Although there are still some open questions that still need to be answered, this study certainly is not just a wink, shot in the dark. Wow, Veronica really cooked with these puns. Veronica is a final year PhD candidate at McMaster University. Very epic, Veronica. I heard a so yeah. Oh no! Oh no! Alright, Orbeez, should I spin it again? I mean, we did finish an article, so maybe we should spin to celebrate. Do you only read papers from Astrobites? This is actually my first Astrobites stream. But if you guys like it, I'm happy to do more. I'm also happy to do actual papers. I was originally planning to do one on cosmological simulations. The issue, though, is that for some of these papers, Astrobites fortunately has a policy where you can stream and share it. For some papers, there are copyright regulations that would prevent me from streaming it, though I would have to look more into detail. Yep, she put a lot of effort into the puns, yeah. Z is actually Veronica is complimenting herself. No, I am not Veronica. I wish I could be as goated as Veronica. That's fire puns right there. Get it? Fire puns. On the topic of, yeah, it's amazing how things at different scales connect. Yeah, exactly. Alright, should I spin the wheel again? Alright, let's see. Okay, let's take a breath. And first, let's determine what name. Certified astrologer wins the poll. Alright, Orbeez. Do you hear the sound of this marker? Do you hear the sound of this marker? 25 words per minute. I hope Astrotropos that you're pausing it when I'm not reading the paper. Do you know about walking droplets? Ooh, I do not. I'm happy to read more though if you have a paper to share. In my IR research stuff, I'm amazed how much of my imaging and galaxy knowledge applies to medical imaging. Yes, there's a lot of connections between physics. Alright guys, I'm writing certified astrologer. TM2? Alright, Eggy. Alright, upper arm, here we go. Oh no. Wait. One thing I want to check though is that this is kind of like... Oh my god. OMG. The line of this like... Okay, I'm using an expo marker by the way because I think a Sharpie would be a little insane. I don't think my arm is like long enough. Forearm, not upper arm. Yeah. I'm writing. I'm cooking. Give me a second. Oh, it's cold. Ah! Oh my gee. It's kind of hard to write with the expo marker. Alright, it's written. Orbeez, I'm going to take a picture of this later. It's going to be on the model, not the actual person. Well, I can't switch up my V-Roy model that quickly. Though, I can write it, like, virtually. No! Why did you subscribe? No! I'm just joking. Thank you, Crocken, for subscribing. Now I have to spin it again. This is what I wrote, by the way. Oh, I guess I can't do... the superscript, but... Oh, what? Oh no, it's Jover! Okay, I'll put it in Comic Sans so it's fun. Oh, what is going on? Oh god, Orbeez. Alright. I don't even know if that fits. Maybe if I can, like, rotate it. And I'll take a picture of these later and I'll send them into Twitter and Discord and whatever. I'll dox my arm for you guys. Z arm reveal. What? I thought Z was a photon. I thought Z couldn't have arms. Plot twist. I am a person. Yes. Next paper should be in Comic Sans. Oh god. Did I do that? Yeah, thank you, Kraken. Alright, 3, 2, 1. If it's writing on my arm again, I'm actually gonna lose it. No! No! Okay, this is not... Okay, this could be worse. I could have another word written on my arm. Alright, I don't want to get copyright striked, but I do know... Okay, let me Google the lyrics real quick. Wait, sorry, let me quickly... what was it called? I think it is Deadbeats. I don't want to put the instrumental in the background just in case. Wow, the first few lines are just Deadbeats lurking now. Let me actually, which one is this? It's this one. Yep. This is great. Alright. Yeah, the first lines are Deadbeats lurking now, Deadbeats lurking. I actually don't even remember what this song sounds like, but I used to actually do this in like karaoke songs. Deadbeats lurking now, Deadbeats lurking down, Deadbeats, yeah, times 3, times 3, times 3. Alright, Orbeez, you're ready for the performance of the lifetime? Clippers, you better get your clip button ready because this is gonna be spectacular. Let me drink some lemon tea to clean my throat. Mylan, hi. We're celebrating, and the Wheel of Doom has told me that I need to karaoke a rap song, so I'm karaokeing the only song I know, which is Deadbeats by Maury Calliope 2020. Alright. Alright. Is it like dun 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 dun? It's kinda like that. Alright. Getting kinda stir crazy, you heard this. I wonder what the meaning of lazy or life without work is. Kawaii Shinigami at your service. Mark enemies and I'll show them what hurt is merciless. But what else should I be? Said a nice guy? Yeah, but that's honesty. A blood price to be paid, but I promise it's worth this. On-demand homicidal circus. All you really gotta do is sign on the dotted line. It's probably fine, right? Psych, your soul is mine. It's all good. Being a deadbeat's got benefits. We'll be best friends. That's the end of it. Then I get a rush of adrenaline. I think I like you. Wanna feel my 5-foot scythe inside you? I would die for you. And an adorable scream. Curious, would you die for me? Why is she good at this? What? And the clown music in the background. I can't even hear it because I don't have the thing. Please, someone send this to Maury Calliope. I want to be noticed by my senpai. Alright, I think that's it. I actually don't know what the rest of this sounds like. Alright. If we get the rap one again, I'll sing the next part, which is gonna be a little bit hard because there's curse words and I do not curse, so yep. 10 out of 10, very nice. Yeah, thank you guys so much. This is an experience. Yeah, exactly. This is an experience. Alright. So, I wonder how fast this will be. This is a short one. I wanted to read this one next. This is actually not astrophysics. It's more like planetary science, but I thought it'd be really, really, really cool to read. Z becomes a marketable plushie. Oh, I've been looking into plushies, Orbeez, but it's been really hard. There's one person that I've been talking to, but the issue is that it's really hard to gauge how many people really want plushies, and getting a huge order is really challenging and having them shipped out as well. I'm thinking that it might be a milestone for when we hit like 5K or something like that. I've tried to reach out to some vendors, but they have a limit. Like, like a minimum subscriber limit or like a channel size that they need you to be at before they start like pre-orders. So even before you start a campaign, so it's been a little bit hard, but I'll keep you guys updated. Post it on Twitter, share on Discord. I gotta send it to my friends. Oh no! Well, plug me, your favorite physics VTuber. There are currently 3 clips in the Discord. Orbeez, you are insane. Alright. I gotta go now, gotta go outside and try and get a job. Oh no, best of luck, professional skill issue. You got this, power through, power through. In the meantime, we're gonna read our next article. Seeding life in the oceans and moons. Oh, that does not count because I technically have not started reading. Moon oceans. All publicity is good publicity. Yes. I will provide a link here. Alright. Impacts in ocean worlds are sufficiently frequent and energetic to be of astrobiological importance. Asteroids and meteorites are usually associated with doom and destruction, just like this Wheel of Doom, but they may have also been essential for the emergence of life on Earth. It is popularly theorized that some of the base building blocks of life, like volatiles and organics, were delivered here by meteorites, and that the energy of these impacts synthesized even more, like HCN and amino acids. Expectedly, the same should be true for other planets. Today's paper explores the possibilities of using nearby analogies for potential habitable exoplanets, namely our solar system's ocean worlds. This is really cool to me because I am one of the people who believe that asteroids could potentially bring life to, maybe not necessarily Earth, but to other systems. Asteroids and comets have water, could have organic materials, which could then develop into habitable conditions and life. HCN is cyanide? Seriously? It's hydrogen cyanide. That's crazy. Well, I guess it probably is a base chemical. It has hydrogen, carbon, and nitrogen, which are all part of schnapps. Or the organic elements that make up life. Why do meteorites carry organics? Yes, the solar system formed from one massive cloud of gas and dust, so the composition everywhere is approximately the same. However, early Earth was an extremely hot ball of magma that destroyed its organic matter. Luckily, organics were able to survive in objects like meteorites in the cold outskirts of the solar system. Yes, and so these organics were preserved. Wait a second. Was my usage of so in that sentence a filler word? I just realized your shirt is the cosmic microwave background. Yes, it is. I am canonically a photon from the first light of the universe. Isn't it dependent on the distance from the sun? Yes, it is. Though what's being implied is that these organics survive inside of the objects where they are protected. I think you're good. Okay, let's keep reading. In the search for extraterrestrial life, we start by looking for the basic necessities, and water is a big one. Though Earth is the only planet in our solar system with water, several moons of Jupiter and Saturn have it as well. They are beyond the balmy habitable zone, so the surfaces of these moons are covered in icy crusts. This is Saturn's moon Enceladus, where there is a literal liquid ocean underneath Enceladus's crust. And my favorite, Europa, has an ocean that is, if I recall correctly, around 3 times more than the Earth's oceans combined. Which is incredible! And they're in our solar system. We don't have to travel light years away to get to them. Legally distinct CMB. Yeah, exactly. This is thankfully created by Mylan to hopefully not give me copyright issues. Enceladus is my favorite solar system object. Yes. I think Europa is better, though. I had a lecturer who was obsessed with Enceladus. I think lecturers are either obsessed with Enceladus or Europa, especially planetary scientists. Or some are obsessed with Titan, even. Yes. On their own, the presence of water makes these moons astrobiologically interesting, and they also elucidate ocean worlds that are further away. Today's authors studied typical impact events on Jupiter's moon Europa, and Saturn's moons Enceladus and Titan, yep, exactly here, to determine if organics could survive impacts, and what processes could occur in the resulting melted material in the impact crater before it refreezes. To evaluate the survivability, the authors model the maximum pressure of an impact on an ocean world's ice crust for a range of impact velocities and angles. Around Jupiter and Saturn, most impactors are either icy or rocky objects that originate from the Kuiper Belt or the Oort cloud, so they model them both. Rocky impactors create higher pressures than icy impactors from the sizes of observed craters on the ocean world moons. Previous works determine the velocities and pressures of impacts, which are shown by the color boxes in figure 2. Finally, a number of other works have estimated the ranges of survivable pressures for biota and biologically important molecules, which are shown by the green and black bars. Basically, impressively, the survivable pressure ranges are within the observed and modeled pressures of impacts. A lot of words here just describing what this plot is. Looks like what's going on here is that the survivable pressures of organics, green and gray color, tardigrade survival is also here, which was really cool. If you haven't seen it already, you should check out my collab with Phi, where Phi taught me about tardigrades and how they undergo a hibernation twin state, which is really cool. I actually really love that stream. And these are within the range of observed velocities and pressures from the craters on each ocean world moon. I guess this is the impact angle, and it shows the velocities of which these impacts can occur. And it's suggesting that bacterial spores or organics can survive, which is really compelling. It means that maybe not necessarily, we're using Titan and Enceladus and Europa as the case study because we know the most about them, but it can also imply for exoplanets or for other systems, we can understand their characteristics and they could potentially be habitable from collisions of asteroids, comets, etc. onto their surface. Yes, thank you Pembu for sending the link. When an impactor hits the icy crust, some of the ice will melt. The deposited organics will end up in a pool of liquid water in the crater, which is an ample environment for prebiotic chemistry until the pool freezes. From the observed crater sizes and modeled velocities, the authors estimated how much liquid water could remain in a crater and how long it would take to freeze. This sounds like a basic science fair experiment, but it's really hard because you have to mimic the crater conditions. Freeze times range from a few Earth years for the smallest craters to thousands of years in labs on Earth mimicking the crater conditions. Amino acids, the organic materials of life, have been synthesized in as short as a few months to a few years, so synthesis is possible in the melt pools that emerge after a comet or an asteroid hits an icy crust. And these pools will eventually freeze, trapping any deposited or synthesized material on the icy surface, which is crazy, and then these could then break through the icy crust and transport material. What this paper is suggesting is that there are a lot of ways that the water or the organic materials can become ingrained in an environment of a moon or a planet just through a single collision, and that these organics can survive these collisions. 20.28 words per minute. I have to rap at this point. If you do more gameplay, you can play Spore. Ooh, the real question is if it is on Mac. Let's see. And it is not on Mac. Unfortunately, I have a Mac computer, so I can't play most games. But I've been recommended that game before, if I recall correctly. Alright, last paragraph. In summary, survivable impacts on the ocean world moons are common, and each provides an opportunity for prebiotic chemistry to arise. Unlike most objects astronomers study, the proximity of these ocean worlds means that we can thoroughly understand them through physical samples. NASA's Cassini spacecraft detected organic compounds in the plumes that burst off of the surface of Enceladus. These are explosions of water material from the surface, and Cassini detected organic compounds. And the Dragonfly mission in 2028 is set to head for Titan and analyze samples once it arrives in 2034. This is really far ahead, but if you think about it, that will be in, what, 3 years or so? In the coming decades, we may witness the discovery of more precursors to life or microbial life itself in the subsurface oceans and moons, and gain radical insight into the ocean worlds beyond. And I'd like to also mention that before this Dragonfly mission takes place, Europa Clipper is currently en route to Europa, which will also help us gather more information about these icy moons. Common Mac L? What? No, I love my Mac. My Mac is great. And this was written by Anelia Anderson. Wow, I'm an astrophysicist. Oh, there's 2 A's in that initials. Astrophysicist. Oh, even more. Astrophysicist PhD candidate at the University of Alabama. Anelia really does love her A's. And we might have a moon landing with Artemis 3 by then. Is what a filler word? I don't think so. I don't think so. I don't think so. But I might spin the wheel for funsies because we just went through all of the articles I wanted to read together, which is great. And the last thing I wanted to show are just some funny papers that I encountered. There's a lot in here. I don't want to overwhelm you guys. I'm hoping that there's no... Oh, I love this one. I'm gonna definitely show this one. There's also one with the Mike Wazowski. Oh, yes. Higher multiples of the cow. This was also great, too. Oh, wait, where's the Mike Wazowski one? Orbeez, you probably think I'm crazy, but... Ah, yes, there we go. I'm hoping that these are fine to share. Wait, before I show these, let me... I'm probably just gonna show it on the Astrobites page just to be safe with copyright, actually. Can you install virtual machine? I can, but I don't know if you guys can hear, but my computer fan is already like at max right now just from streaming, so having a virtual machine would not be very pleasant. Higher multiples of the cow. Alright, we're gonna spin the wheel and then I'm gonna talk about some of my favorite papers from April Fools. If you guys don't know, for April Fools, some researchers publish these really funny papers. I mean, we can go over the first one right now. I mean, it's just a plot showing different hotspots using Mike Wazowski. And somehow it's connected with pulsar X-ray emissions, which is really funny. There's also this... Alright, before I continue, I will quickly spin the wheel. Yeah, no, these are so good. I'll go more into detail in a second. Oh. Oh, no. Uh-oh. I think I'm frozen. Uh-oh. Oh, what is going on? Oh, no. Oh, no. Oh. Okay, we're back. We're back. Okay, everything's back. Here, let me restart this page. The tracking's still going, but... Oh no! Alright, let me... This might be an indicator that I might need to wrap up soon. Alright, we're gonna do one last spin the wheel. Is that the end of the papers? Yes, it is. I think I ended up second place. Phi is just too goated. Alright, let's spin the wheel. 3, 2, 1. No! Okay. Stand on tippy toes. Okay, I would do this, except that we don't have any more papers to read, and that would require... I'm sitting right now, so that would require me to, like, bend over. We would need to wrap up. Alright, we're gonna spin again. We're gonna spin again, just so that I can do something really quick while reading the April Fool's papers. Oh, this is a cute one to end on, guys. Remember to hydrate. I will do that right now. This is a really calm way to end the Wheel of Doom. Orbeez, remember to stay hydrated. And I think that's the last of the Wheel of Doom, unless something diabolical happens. Like someone subscribes, or I say a really bad filler word. Hydrate or dihydrate. Let's quickly go through these. This was one of my favorites because it's a way to create pasta maps. Actually, let me see... I think I can pull the GitHub page without having to worry about copyright issues. Oh, I can, but I'm in dark mode. Open image in new tab. Oh, that is really blurry. Yeah, I mean, I can show this. It's showing how you can make your plots out of little pasta. It's so funny. You can make little pasta things. And you can do this just by installing the pasta markers package on GitHub, which is really cool. And that was one of the papers that we're describing here. You can have a pasta plot, and then, oh, maybe I can just zoom in here. And then you can add cheese to it. Isn't that so funny? I thought this was the cutest thing ever. Was it the Astrobites that had the advertisements one? Yes, that was my next favorite. Yes, it's right here. I think this will be the last paper I show for today. You have stolen the first place for highest internal words per minute from Psy, so she's back to just being the— No, how is Psy at 0 words per minute? This was my favorite April Fool's paper this year, actually. It's this corner plots here, where in a corner plot, you have these plots along the diagonal and you have this empty space. And the author suggests that you could fill up that empty space with advertisements to support financially struggling academics, which this is beautiful. And they even got like NordVPN and HelloFresh and BetterHelp and Amex and Duolingo in there. So this is my favorite. She just over-recorded once, but she's the only person to open a paper and stream for like an hour without reading it. Nuh-uh, I'm gonna have to talk to Syzygy after this one. That is not acceptable in the V theorem community. I'm just joking. I'm just joking. This is too close to— yeah, no, the reason why it's funny is because it is too close to being real. But yes. Anywho, that's all for me today. Yes. So if you want, I think I'm safe now to say filler words because we finished reading the paper. If you haven't already, go to astrobites.org. They have a lot of really great information about articles. If you click the 3 bars here, you can read these daily paper summaries where they explain all this different research, and they post around every single day. So every day there will be a new paper to read. They also do papers for career navigation, personal experiences, so if you're interested in doing astrophysics research or seeing how you can get involved with citizen science or so forth, they also have resources for that. They also have more opinion articles, especially given today's political climate. I tend to avoid talking about politics on stream, but I would recommend that you check out these articles. I really, really loved this one, the NASA Needs Your Help article, which was an absolutely devastating read. But the reason why I loved it wasn't because the news was good, but because they did a really good job of explaining how bad this issue is right now. Yes, astrobites.org. And they also do, they go to conferences and they share some stuff there. So yeah, definitely go check it out, astrobites.org. Thank you, Pembu, for also sending it into the chat. And if you haven't already, if you are new to the channel, I know a lot of you guys found me after the publication announcement. Go join the Discord! Oh yeah, where should I put the data on Discord? Feel free to put it into the general channel. There's also a V-Theorem channel in like Syzygy's Discord or something. Somewhere like that is cool too. Woohoo! Thank you so much for the congratulations messages on getting published. Let me see if I have any last minute announcements. Oh, I'll take a picture of the words written on my arm. Oh my god, I don't even know how to feel about that. And I'm glad you guys had a lot of fun. Hopefully we'll do the 2,000 subscribers celebration milestone again soon, and maybe we'll bring back the Wheel of Doom for that as well. Who knows? And maybe I'll do a rap concert. Who knows? It's absolutely awesome that you got published. Thank you. Thank you, thank you, thank you all so much. It was a brilliant stream as usual. Thank you for getting published. Yes, yes, thank you. Hitting 2,000 subscribers was a crazy milestone. Alright, I think I gotta wrap up now. But I will see you guys in the next one, and until next time, which I think might be Sunday, we might play some Kerbal Space Program if I have some time. Or we'll do something chill, we'll see, maybe a study with Z. I'll keep you guys updated. And next week there's going to be an epic collab, so a lot of really cool things to look forward to. Oh, and before I forget, that actually reminds me. Sorry, I'm gonna do something really quick. I realized that one thing that I want to do more often in these streams is actually make an active effort to try to redirect people to other streams. Oh, well, I guess no one I'm subscribed to is streaming right now, unfortunately. Let me see. Here, I'll just redirect to Phi's stream. So Phi's doing a stream on the 21st on prions and melanomas, so be sure to check that out. Yeah, and if you guys have any suggestions for science VTubers that I could potentially help support by, like, redirecting, which is basically, like, YouTube's version of, like, Twitch Raid, I'd love to also hear more. Alright, cool. Until next time, I'll see you guys later. Bye-bye! 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 Stay hydrated, stay safe, stay happy, live, laugh, and love. Thank you all for the congratulations messages. Bye-bye! Bye-bye!